video is to review solving radical equations. What's important with solving radical equations is to really think about how you would solve a normal equation. So you're really thinking about, your reverse order of operations, and you really want to isolate the radical, get the radical all by itself before you square both sides or cube both sides, etc. And then I'm going to write this at the bottom. You always want to check your solution to make sure that it works. And I'll show you what I mean by that in a second. So we have 3 examples we're going to do. Let's do the first example here first. So like I said, you want to think of this radical almost like parentheses. We want to isolate that. So the first thing we're going to do is add 4 to both sides. We want to get that radical all by itself. So the square root of 2m squared minus 10 is equal to 8. Now that we have the radical all by itself, this is where we want to get rid of the radical. So we want to do the opposite of taking the square root, which means we want to square both sides. So now we have the square root and we have the square, so they're inverse of operations. So they essentially cancel each other out. So on this side, all we're left with here is 2m squared minus 10. But on this side, we've done 8 squared, so we have 64. So now, again, it's just like solving an equation. We're trying to get this m value. So we add 10 to both sides. And then we can't do the exponent yet. Okay, we're going to divide by 2. So 74 divided by 2 is 37. I'm going to continue up here. We have m squared is equal to 37. So from here you can kind of see, okay, we're going to take the square root of both sides, and what our answer is going to be, m is equal to the positive and negative square root of 37, which is answer choice A. If you had an answer choice, especially of no solution, you would want to make sure and check your solution here to see if this was actually a valid solution or if it were an extraneous solution. And I'm going to show you on the Inspire especially what you should do. You should store your value of your solution. So in this case, and I'm only going to store the positive value of the square root of 37, the STO, okay, is what I want. So I want to store that value here. And I'll store it for m. I want to make sure I get out of that square root before I store it for my variable. Okay, and it spits that back out at me, and then I type my equation exactly as I saw it. Okay, so 2m squared minus 10. I get out of the square root because then it said minus 4. And then it was equal to 4. Okay, and it tells me that it's true, so I know that that's a valid solution. So let's try our next example here. Okay, very similar. You could try this one on your own, pause the video, and then check to see if you got the correct answer. If you wanted, I'm going to go ahead here. I added 3 to both sides. So I have the cube root of x squared plus 8 is equal to 3. So now I've isolated my cube root here, which means I'm going to cube both sides, do that inverse operation. So they cancel each other out. So I'm left with x squared plus 8 is equal to 27. Now I'm going to subtract 8 from both sides, so I get x squared is equal to 19. Then I'm going to take the square root of both sides, so that I get x is equal to the positive and negative square root of 19. I should check my answer just to make sure. I've already done that, so I know it's a valid solution. The correct answer here is A. And one more example here with a rational exponent. I'm trying to solve this equation here. It works exactly the same. I'm trying to isolate this part of it. So the first step that I'm going to do here is I'm going to subtract 4 from both sides. So I have 3 times x minus 1 to the 2/3 power is equal to 48. Okay, I don't want to use this yet. Okay, I want to get rid of that 3 first, which means I'm dividing both sides by 3. So I have x minus 1 to the 2/3 power is equal to 16. Now when you have a rational exponent, to do the inverse operation, you want to take it to the reciprocal power. So I'm going to take this side to the 3/2 power. 2/3 times 3/2, it's what's going to get that to cancel. That's the inverse operation. So if I do that to one side, I have to do it to the other. So again, these are inverse operations. They cancel each other out. We're left on this side with just the x minus 1. 16 to the 3/2 power is 64. Now what's really important here is that you're taking 16 to the 3/2 power and not multiplying by 3/2. And then from here, all we're doing is adding 1 to both sides, so we get x is equal to 65. Now again, you should plug that in and make sure that it's a valid solution. It is. I've checked it, so I know that it works. If you have more questions on solving radical equations, please see your math teacher.